All right, we are graphing quadratics today. So we have a standard form for all quadratics, which is written as ax squared plus bx plus c. And these coefficients, a, b, and c, are going to be very useful to us in a little bit. Let's start filling in some blanks. A graph of a quadratic. When graphed, a quadratic equation creates a U-shaped curve called a parabola. And these are the type of quadratics that are parabolas. Here we go. We got x squared plus 2x minus 5. We're going to use our calculator to sketch this out. So we're going to go to y equals x squared plus 2x minus 5. Hit a graph. We're going to try our best to replicate this graph on our paper. So it goes from up here down to there and back up. I'm going to put little arrows. Our next one, let's clear that, negative x squared plus 3x plus 7. And we see this one looks a little different. We're going to do our best to make it look exactly like it. Start from the bottom, up like that. And those are our parabolas. All right, so one is opening up, this one right here, and the other one is opening down. And we look at our a coefficient, the one that goes right there in front of our x squared. If a is positive, then the parabola opens up, like a little smiley face. If a is negative, then the parabola opens down. So this one right here had a negative a coefficient, so it opens down. And this one had a positive a coefficient, so it opens up. Now let's talk about our axis of symmetry. Our axis of symmetry is the line of symmetry for each parabola. If you look at our parabolas, our axis of symmetry for this one goes right through there because it mirrors the left and right side. This axis of symmetry would be right there and mirrors the left and right side there. So we have a formula for our axis of symmetry, and that one is x equals negative b over 2a. So our x equals negative b over 2a is our formula for our axis of symmetry. And then we have to look at our vertex. Our vertex is our turning point for the parabola. It happens there for that one. And if we look over here, it happens there also. When the vertex is the lowest point, we call that a minimum. When the vertex is the highest point, we call that a maximum. So now we're going to use the axis of symmetry to find our vertex on this example right here at the bottom. And so first we need to figure out what our a, b, and c coefficients are. So for this problem, we have x squared plus 8x plus 15. We're going to write down a equals 1 because that's what the coefficient of x squared is. Our b coefficient is 8, and c equals 15. For our axis of symmetry, we need our formula, which is x equals negative b over 2a. And all we have to do is replace the b and the c and the a into this formula. We don't need a c, actually. So we have negative, parentheses 8, all over 2, parentheses 1. Use our little calculator here. Negative 8 over 2, 1. So our axis of symmetry is x equals negative 4. Now, we need this axis of symmetry to find our vertex. I'm going to do that right now. So we know that the axis of symmetry is x equals -4. Our vertex can be found using this value of x in this equation that we are trying to find it for. So we go y equals -4 squared plus 8. -4 plus 15. So we use our calculator again. Parentheses -4 x squared plus 8 -4 plus 15. We get a y value of -1. And our vertex requires both the x value and the y value, so our vertex is -4, -1. So now let's sketch it. X squared plus 8x plus 15. A graph, and it looks like that. So here is what our graph is supposed to look like. And this point right here is our vertex, and that point right there is -4, -1. And our line of symmetry happens right there. And that one is x equals -4. All right, we have a back to these notes, and we're going to do those in class tomorrow.